Uh, Now let's talk about the third case where no external force is applied and when the block is placed on a inclined plane. Okay, the plane which is making some angle alpha. So we have an inclined plane which is making an angle alpha and the block is placed over that plane. So as we know, there are two forces active on the block. One is reaction force, another is mg. Okay, so mg is obviously acting downward. Mg would be this force which is acting vertically downward, and this mg will make an angle alpha with the line which is directly opposite to the reaction force. Understood? Let me check how does this mg makes an angle alpha with r, with this line of r. For that, let me draw the simple diagram. This is alpha as we know it. Okay, so mg is acting this way. Mg is acting this way. This has to be straight line. This is 90 degree. So if this is alpha, then this has to be 90 minus alpha. This has to be 90 minus alpha, so that the 90 plus 90 becomes 180, minus alpha plus alpha get cancelled, so that the sum of these three angles becomes 180. Therefore this has to be 90 minus alpha, and we know this is a line of reaction, normal reaction. Okay, this is the line of normal reaction force. Obviously this will make an angle 90 degree. This line and this line will make an angle 90 degree, so this has to be 90 degree. Let me draw it here. This has to be 90 degree, no? If this is 90 degree, then this has to be alpha, so that this becomes 90 minus alpha. If this is 90 degree, then this has to be alpha, so that this becomes 90 minus alpha. Understood? So therefore we got this as alpha. I hope you got it. So this is alpha. Now mg has two components. Mg, the side with which the angle is made with the cos term. Always remember, the side with which the angle is made is cos alpha term, and the opposite side, this is mg sin alpha term. Okay, now we write it in the equation. R equals to mg cos alpha, because this force is this normal reaction balances this force mg cos alpha, and this mg sin alpha is actually making it fall down, making it accelerate downward. Therefore mg sin alpha can be written as a. From there we can write a equals to, a is only mg sin alpha, I'm sorry. So we got the expression of acceleration of a block which is placed in an inclined plane where there is no external force. Okay, that would be due to this mg sin alpha term. So I'm sorry, I just cannot write a over here because this mg sin alpha is the force and a is the acceleration, so I have to write ma over here. So finally this will give you m into a. So finally a equals to cancels out, this m and this m cancels, it becomes g sin alpha. So this is the acceleration produced.